Hello everyone, welcome to DCC YouTube channel, and today we are going to discuss the third problem of today's weekly contest, that is minimum deletions to make a string k special. And we are given a string word and an integer k, and we consider word to be k special if the frequency of word I minus frequency of word j, the absolute value of this, is less than or equal to k for all indices I and j in the string. So here frequency of x denote the frequency of the character x in the word, and mod y denotes the absolute value of y. Return the minimum number of characters you need to delete to make word k special. So let's understand the example. So this is the given example, that is AA, BC, ABA, and the k is 0. So like if the k is 0, they are asking us to delete the characters so that the frequency of every characters is equal, because the difference have to be 0, that means the frequency have to be equal. So here what they have done is that we can make word 0 special by deleting two occurrences of A and one occurrence of C, and therefore the word becomes BA. So in this particular string they have deleted C, and also they have deleted two occurrences of A. So finally the string has become BA. So the unique characters in this string are A comma B, and the difference of this frequency is 0. So and it completely satisfies this condition, and it is 0 special. So they're asking us to print the minimum number of deletions to make this case special. So first, if we think about this, so first if we take the minimum frequency, that is 1, that is C. So if we take this and if we keep on deleting the other characters, making all other characters as frequency 1. So for example, okay, so let me show you. Yeah, okay, so in this example, like I have took this string and I have made the frequency array, that is this, and then I have sorted the frequency array, and after sorting the frequency array, it is 1 2 4 5, like as in A is repeated 4 times, B is repeated 2, C is 1, and D is repeated 5 times. So similarly I've just made this array. So now our task is to find the minimum number of deletions. So we have two options actually. The first option is that we fix a minimum element. So if I'm thinking not to delete C, then I have to delete the other occurrences of other characters. So if I decide not to delete C, then I have to delete all other A's except one A, all other B's except one B, and I should delete this all four D's, because the difference of the frequency of these characters have should not exceed 0. So that's why if I delete all these four D's, then one would be the frequency of D, one would be the frequency of C, and that would satisfy the condition. So if I decide to delete C, then from these four characters of D, and then two this character also I'm going to delete, and two A's, so three A's. So in that way I'll find out the number of deletions if I decide to not delete C. So similarly, if I then decide to delete C, and then if I don't, if I decide not to delete B, so then the minimum frequency would be 2, right? So the minimum frequency would be 2, and then I have to make this 4 and 5 as 2, 2 comma 2. So to make this 2 comma 2, we need to subtract these values, so that is 5 minus 2 and 4 minus 2, and also I need to delete this C, because uh, to satisfy the condition this C should be deleted, so it might be like 1 plus 2 plus 2. So for similarly we have to try to find out the values for every character, that is B, that is A, and then D also. So if we try for A, then these all B's and C's should be deleted, that is these both have to be deleted, and this has to be like 4, so that is 5 minus 4, and the operation would increase by 1. So yeah, to actually find out this, the constraints given in the problem are like 10 power 5, so we can do it using n log n. So to do it using n log n, it is better that we maintain a prefix sum array, and prefix sum array of this frequency array, and then we need to find out the other element, and using the lower bound, and that would give us the log n complexity, and we need to iterate through every of this elements, because to find out whether this is the minimum element or this is the minimum element, this is the minimum element, this. So that's why we need to iterate through this whole, and using upper bound we need to find the number of operations, and out of all those operations we need to consider the minimum operation and return that answer. So let me look into the code. Um, yep. So here we have just made the like we have counted the frequencies of every character, and here we have made the frequency array, that is m, and we sorted it, and then we made the prefix sum array of that frequency array, and then in this for loop we just counted the number of minimum operations. That is, first we did the lower bound of p, and then here we counted the number of operations, and here we are doing sum plus is equals to m of I, because we are also deleting the characters with the minimum frequency, and at last return the minimum number of operations. So this is it, and thank you.